There is considerable overlap in the abilities of PBr3 and HBr. Both of them can take an OH group and change it into a bromide. In the simplest case example, right here, HBr and PBr3 are pretty much interchangeable. You can use one or the other. Now, the thing about HBr is is very, very acidic, and it can react with other functional groups, and this can lead to byproducts. One of the functional groups that acid can react with are alkenes. And so in this example right here, where we selectively change the OH into Br, the best choice is to use PBr3. HBr can also activate ethers by protonating this oxygen of an ether. And so in the next case example, where we have to selectively change the OH into Br when there's a methoxy group present, PBr3 is the better choice, because PBr3 reacts with alcohols and leaves ethers alone. Now, if you really did need an ether to react, like in this next example right here, you need to use HBr. This PBr3 won't react with ethers, so you need the HBr to protonate this oxygen here, and you turn this entire group into a good leaving group, which the bromide can add, and you get this into an SN2 reaction. Another example where you need to use HBr rather than PBr3 is when you're dealing with tertiary alcohols. PBr3 does SN2 only. It can't do SN1. And so as a result, you need to use HBr for this particular reaction. Now, the bottom case. At first glance, you can pretty much use HBr and PBr3 interchangeably to get this transformation. But PBr3 is the far, far better choice. It's because PBr3 limits the amount of Br minus present at any one time. Why this is important is halfway through the reaction using HBr, you have the protonated version of this, and you have your product. Bromide, if you have too much of it, what will start happening is bromide will start attacking your product just as quickly as it attacks your starting material. If it attacks your product, then you generate a bit more of the inversion here. As a result, HBr can actually lose optical activity. You don't get a total loss of optical activity because this is still minor, but you can get some. PBr3 has less losses of optical activity because the amount of Br minus present at any one time is severely limited.